So these ones here, we were dealing with perfect squares. Perfect squares can have decimal side length, and we can still have a perfect square because this is an exact side length of 2.5, exact side length of 6.7. These are still perfect squares. So when we're dealing with squares, perfect squares is great because it's easy to go from squares to square roots. So I have 64 squares here. My side length, to get 64 squares, I need an 8 by 8 side length. So my side is 8 units. And if I can draw 8 units along the side, actually sketch in 64 squares here. Here the area is 81. 81 is a perfect square, so the side length is exactly 8 units. So for C, it's 49. Again, 49 is a perfect square. So I can just say that the side length says 49 squares in here, so there's 7 units along the edge. 25 is going to be from a side length of 5 units. Okay, so if I draw 5, 1, 2, 3, 4, 1, 2, 3, 4, I can count actually 25 squares in there. There's 5, layer 1, 2, 3, 4, 5, and there's 5 layers of 5, which gives me the 25 squares. When it comes to 60 squares, it's going to be really hard to draw 60 squares in here, but this is exactly 60 squares in there. Okay, but the problem is the edge length. I can't draw squares in here like this. Okay, because the edge length, if I make it 7, it's too small. If I make it 8 full squares, it's too big, and I have too many squares. So it's got to be somewhere in between. And when I work out the edge length, again, we're going to just undo the square with the square root. And so when I undo that square with the square root, I do the square root of 60. I get this really, really long decimal, I get 7.7459 ... Okay, it keeps on going forever. So this is a really awkward side length. Now, if I need to express this exactly, I would have to do this as square root 60. Same thing here. To find exactly 70 squares in this area, I need an edge length of square root 70. And again, if I plug that into my calculator, it's not a nice number. Okay, if I go 70 square root, it gives me 8.366600. Okay, so it's not a very nice number. Okay, so 8.3660, sorry, 6660 ... So these are irrational numbers. These are not non-terminating, non-repeating decimals, and these are not very nice. So these side lengths are not rational numbers. Okay, so what's the difference between E and F and the others? Well, these E and F, the E and F questions, okay, they are not rational numbers, meaning that they have non-terminating, non-repeating decimals. Non-repeating decimals. Oops, spelled that wrong. Repeating they are not nice numbers to work with. Okay, the decimals tell us about how long they are and how big they are, but they don't really let us do the math on them very easily. So we need to be able to recognize that some of these numbers are not going to be exact values. And when we don't have calculators, we need to at least be able to estimate. So when I talk about a square of 30 squares, and I want to square root it or find the edge length of a square with 30 squares, I need to know that this square is bigger than a 25 square. So it's got to have an edge length of 5 units, bigger than 5 units. Okay, so the side must be bigger than 5 units. But I also know that it has to be shorter than 6 units because it's got to be smaller than a 36 square, which is a side length of 6 units. Okay, so we need to be able to estimate the square root. Now, if I were to estimate an actual value, I'd say the side is equal to approximately, I'm going to go somewhere in the middle, 5.5, and that's good enough. That's all I really expect you to be able to do. Any decimal in between. Now, we can't really say that it's exactly 5.5, okay, but we know it's somewhere in between 5 and 6. If you guess a number somewhere in there, that's good enough. Okay, so 5.5 is not quite going to give us an area of 30. Okay, in fact, 5.5 if we squared, let's try that on our calculator. So 5.5 squared gives us a little bit bigger than 30, so 30.25. But so that's not a bad guess. That's pretty good. That's pretty close. And we only need to get close. So to do these estimates, we do really need to know our perfect squares. Okay, so 238, we need to know the perfect squares that 238 is in between. Well, 225 is a perfect square of 15 squared. Okay, so we know that this is going to be somewhere between 15 and so the next square is going to be 16 squared. Okay, 16 squared is going to be 256. So it's between 256 squares and 225 squares. So the side length must be somewhere between 15 and 16 units. Okay, and if we were to guess this, we can guess, 15.5 if you want. Okay, we can, if you think that maybe it's closer to 15, you can guess less, you can guess more. It doesn't really matter. It's hard to really guess once we exactly where in between 15 and 16 it is, okay, because it's not what we call a linear guess either. Okay, so it's not a straight line guess. So we're not expected to do this other than to know that somewhere in between. If I said 15.4, that would be good enough as well. Yeah, I'm just going to leave it right in the middle though, say just 15.5, knowing that that's not quite correct.